Yay, thank you for that thumbs up, Denise. All right, welcome everyone. Feliz Cinco de Mayo. Yesterday was May 4th. I don't know if anyone likes Star Wars, but
It's my
yesterday.
daughter's birthday
Oh, and today or yesterday?
yesterday.
Yesterday. Happy birthday to your daughter, Elizabeth. May the 4th be with her.
Yes.
And then today, y ahora, Cinco de Mayo. Well, welcome everyone. Thank you so much for being here again. We appreciate you making the time from your busy evenings to spend with us and engage in learning through Count, Play, Explore initiative. If in the chat you can just please quickly drop your name, your role, your district, or organization that you currently work with. And then while you do that, it is May. I was in a session uh, a couple of days ago, and someone said, "Oh, May and October are just so busy." And I was like, "Yes, you're right. October and May are those months that we just feel like there's a million things going on, right?" And one of those things is graduation or promotion season. And so it's May. Shout out anyone in the chat who you are celebrating, who is either a graduate, promoting from one grade from I don't know, from elementary to middle school, right? A friend. Or if you don't have anyone, let's do a throwback and give a shout out to yourself and share in the chat, right? What year you graduated, maybe what program you graduated from or university. And so let's just take a quick few minutes to share in the chat. Does anyone have any special in their life that's graduating? Yay! Shout out to your 1-year-old daughter that is beginning to take her first steps. Yay, Lucia. My daughter this year is promoting from elementary school to middle school. I know. I know.
No babies.
I'm excited to see her grow and I'm excited to like see her right just I don't know do all the things but also I'm like no my baby's going to middle school. So a lot of mixed emotions but yes happy to be able to witness this part of her life right as she see her growing up and start that like preteen attitude. She does roll her eyes at me sometimes now. But again, if in the chat you have anyone special or yourself, celebrate yourself, and do a throwback and celebrate the year you graduated or where you graduated from. You have your niece's graduation, Melanie is graduating from high school, and Mia's promoting to high school. Yay, felicidades, Laura. Your niece is starting kindergarten this year. Oh, that's exciting. Yeah,
Feel
I
sorry
feel
for the
like
teacher.
did she do TK Veronica?
No.
No, no TK. Yeah. So my daughter too did preschool to kinder, right? Did your niece do any pre-K?
Yes. Hmm.
Yeah, but still that transition feels like, whoa, this is real school now, right? Not that preschool isn't real school, it is real school, but just a lot more structured, a lot more rigorous. And
Well,
so,
she's been in a home daycare,
oh, okay, okay.
right? But still, I mean, the her teacher is very good, and so, but my thing is that she turns 5 on August 29th.
That's my birthday.
Okay, happy birthday in advance. But I mean, and then she's fine right away. Like a new 5, so
So she'll
we'll
be
see.
one of the youngest students in that school year, right? Because would she have been born a couple of days later, she would have started a whole year later, right?
Yeah. Mm-hmm.
Yeah.
Mm-hmm.
Yeah.
So
Well, sending your niece all the good luck vibes and well
we'll
wishes for her
see. I
new
say
kindergarten.
I feel sorry for the teacher, but
They'll be good. They'll all be good. Thank you so much for sharing. All right. Anyone else? Did I miss anyone in the chat? Nobody did a throwback and celebrated yourself from when you graduated? It's never too late to celebrate ourselves.
So I'm
All
trying
right.
to remember what year did I graduated. It's been like 10 years, 11.
Yeah, we should have graduation anniversaries, right?
I know. It's just that, time flies so fast.
Yeah, Elizabeth just shared 1992, I think. Well, congratulations to all of you because graduating, finishing not only high school but college, universities, all our programs, right, is a huge achievement. And so also when you're celebrating others, do a celebration anniversary for yourself. BA in admin. Thank you so much, Elizabeth, for sharing. All right. We are going to move on, and if you haven't already, if you can please complete the attendance form for today. I'll drop the link in the chat. And then the title of today's session is Building Meaningful Addition and Subtraction in Early Learning. And so I'll give you just a couple of minutes to complete the attendance form. And as you complete the attendance form, we have the link to the participant folder. So just a reminder, right? You're all familiar with this. We use it in every session, but this is where all our resources are housed. The copy of the slide decks are housed. And so just a reminder, right, that it's there for you um, to access whenever you want to come back and visit the slides, right, or are ready to use any of the resources we've previously shared with you. Some reminders for you to save the date. We have our upcoming coaching sessions, right? And we have two options for you, May 14th and May 19th. And so if you can attend either one of those, right, you have options. They are scheduled from 3:30 to 4:30. And also maybe we can think about, right, if you're missing some of the coaching sessions and you're available on both dates, right, maybe you can make up one of the previous coaching sessions that you've missed on one of those days. And so just some options for you. Um, as we are coming to the end of the year, right, we will be reaching out to all of you in case you're missing any PDs or coaching sessions, and work with you to find ways to make those up, right? And so today, we have our session, Building Meaningful Addition and Subtraction in Early Learning, right? Which is, I was going to say penultima. How do you say penultima in English? Penultimate, right? I don't know if that's a word that we use often. But this is a session before our last session, scheduled on June 2nd from 3:30 to 5:30. And so that will be our last professional learning session for the year, right? And that one we are looking at focusing on STEAM for all, sparking inclusive learning with UDL. And so if you can also, if you haven't already, I'm going to drop the link in the chat so that you can register. Oh, thank you, Denise. She already dropped the link in the chat so that you could register for our next session. And so our goal, right, is to have all cohort members complete all requirements that includes the PD sessions and the coaching sessions by latest the June 30th, right? And so you still do have some time, but we want to make sure that we get ahead of that. And so again, like I said, Denise and I will be reaching out to all of you just to make sure you all have what you need and all of the requirements, right? The participation requirements. And so with that said, right, we have we're happy to be able to offer some incentives for you all. And so if you've completed all PD sessions up to date, you will very soon be getting a $50 Amazon gift card, right? And so for the Amazon gift card, um, we won't be asking for any receipts, right? But the intention is that you use the Amazon gift card to perhaps purchase any materials that you might have seen in the session that can support with implementation in your classroom. And then the second Amazon gift card you will receive after completing today's PD session and then that one scheduled in June. And so after you complete those two, you're eligible to receive a second $50 Amazon gift card. And then your third Amazon gift card you can receive once you've completed a total of 3 coaching sessions, right? And so hopefully just something to help, right? Again, with purchasing materials that you might need um, to get rid or are not available through your schools or your school districts for implementation with any of the activities in the sessions that you've seen so far. All right. And so with that, we are going to move on to today's session titled Building Meaningful Addition and Subtraction in Early Lesson. And so in today's session, we're going to explore how children, all the way from preschool, right? So our youngest learners in preschool, TK, kindergarten, first and second grade, develop an understanding of addition and subtraction, right? And we're also going to focus on ways that we can support children, again, to understand and to use addition and subtraction, right? And so today's session came as from feedback, right, and a request, I'm sorry, from participants from when we did our counting session, right, and participants requested more focus, right, on specifically addition and subtraction. And so hopefully you all find today's session meaningful and helpful, right, in supporting your students with addition and subtraction back in your learning spaces. Just a reminder that today's session is made possible through the Count, Play, Explore initiative, right, which is an early math, science, and computer initiative led by the Fresno County Superintendent of Schools, Early Care, and Education Department. The initiative is generously funded by the California Department of Education and the California State Board of Education. And so huge thank you to them, right, for making this work possible. All right. And so some of our sessions goals for today, we are going to work to understand how children in preschool through second grade develop and use addition and subtraction knowledge and skills, right? And so basically how children engage in solving addition and subtraction problems. And we're also going to explore ways educators can support children's understanding of addition and subtraction. And so those are our goals for today. But before jumping into those, I want us to begin with a short game of true and false, right? And this will help us just explore some ideas about addition and subtraction. And so if you joined us for the last session, same process, right? I'll display a statement on the screen, and then you can just think to yourself, it's totally up to you, or you can share in the chat, right? If you think the statement is true or false. Just a reminder that this activity is meant to get us thinking about addition and subtraction, and so absolutely no pressure, safe space, right? No one's saying, no, you got the wrong answer. That's not what this is about. This is just to get us thinking about addition and subtraction. All right. And so here, oh, and that's the answer. Oh no, it didn't work. This is supposed to be an interactive slide. And I'm afraid that's probably gonna happen for all of them. Why did it do that? Oh no, it's not working. Okay, well, we can go through each statement. We're gonna have to pivot. There goes my true and false game. We're gonna have to pivot, but the first statement is adding and subtracting should always involve written numerals. And so adding and subtracting should always include written numbers. And so I know, false, right? We know that that's false, and I see some of you shaking your head, right? And yes, you're absolutely right. Written numerals are not necessary when adding and subtracting, especially for our youngest learners, right? And are younger children who begin adding and subtracting using physical objects without ever using written numerals, right? Or much less written equations. Let me see if I can delete these and refresh the page. I don't know why these didn't work. Give me just a second. All right, I'm gonna exit and refresh and see if we can go back to our, all right, there it goes. All right, statement number 2. True or false? So now you can think about it. Now you can put it in the chat, right? Children can understand addition and subtraction before they begin to count. So what do you think? Is this true or false? Right, and I see some of you nodding your heads. If you want to put it in the chat, you can. You don't have to. Again, just start thinking about subtraction and addition, right? But children can understand addition and subtraction before they can count. Yes. And so this one is absolutely true, right? And so children as young as infants understand that adding will make more, right? And taking away will make less. And that's the very, like the most the foundational, right, conceptual understanding of addition and subtraction. And so again, children as young as infants understand that adding will make more and that taking away something, right, will make less. And so even before children can begin to count, they're able to notice changes in quantity, right? And so you're absolutely right. This one was true. All right, next statement. Children should be discouraged from using their fingers to add or subtract, especially as they get older. All right, so should they be discouraged from using their fingers? I think I still do. I think I still use my fingers. Does anyone else still use their fingers? And so this one is false, right? Oh, and then the statement right there at the bottom might have given it away, right? But children use their fingers to add and subtract, just like they might use other concrete objects such as counting chips or blocks to add and subtract, right? And in fact, using fingers to add and subtract in the early years can actually help children solve addition and subtraction problems with more accuracy, right? So their fingers are a tool that can support children in solving addition and subtraction problems. Now, I've heard this before, right? As children, they get older, they need to move away from that. Well, they might find other ways, or we might support them in finding other ways that are more efficient, right? That are faster and more accurate, but they certainly shouldn't be discouraged from using a tool that is easily accessible, right? It doesn't harm them, while we are also, right, supporting children in finding other faster, more accurate ways to support them with solving addition and subtraction problems. All right, next one. And I think that statement at the bottom is going to give it away. But true or false, children can add and subtract more accurately if they know the count sequence. Is this true or false? Does knowing the count sequence help children add and subtract more accurately? False, true, false, true. This one's a tricky one, right? And so CPE says it's true. Now, they don't have to know the count sequence to add and subtract, but it can definitely help support children do so, solve addition and subtraction problems more accurately, right? And so a child's ability to add and subtract advances when they know the count sequence and can use number words to communicate about quantity, right? And so children can understand that adding makes more and taking away makes less before they count, right? However, children's ability to add and subtract advances when they know the count sequence and they can communicate, right, about quantity. All right, next one. And so true or false. And so we're looking at the statement at the top. Children should use flashcards to memorize addition and subtraction cards. They should use flashcards to memorize addition and subtraction facts. True, false, true, false. And so this one is false, right? And I think that statement at the bottom gave it away. This was supposed to be a slide with animations, but they didn't quite work out. But this one is false. And so children don't need to use flashcards to memorize addition and subtraction facts, right? And so for most children, using flashcards or other rote memorization tasks isn't always the most effective way to help them remember addition and subtraction facts, right? If children memorize addition or subtraction facts without having a strong conceptual understanding of the relationship between numbers, right, then their knowledge is less useful. And so children who only memorize facts through these rote type of experiences, right, will often struggle to apply the facts to new and more complex problems, right? And so we want to move away from activities, right, that rely on the memorization of facts. And so that brings us, this was the last true and false question. Sorry it didn't work out the way it was planned still. I think we had good conversation and good participation in the chat. So thank you so much for being a good sport. And even though it didn't quite work out the way we intended it to, I hope you still, right, began to think about addition and subtraction. All right. And so now we are going to watch a short video clip, right, of adding and subtracting. And so we're going to observe children using addition and subtraction. And as you observe the clip, right, I want us to take notice on how children add or subtract and also the way that the educators are supporting them, right? And so you might consider ways maybe that you've noticed the children in your own settings, right? And how they engage in adding or subtracting in similar ways as you see in the video or in different ways than from what you see on the video. And so we do have two options. I'm going to give you the option. Would you like to see adding and subtracting during snack, right? Oh, I'm sorry. That's the one. You don't have an option for this one. We're all watching it. Give me just a second. Oh, no, hold on.
Wonder how many crackers we have.
Now let me share with you. And I'm going to...
Wonder how many crackers we have. Do you think everybody has the same? Yeah, you think so? I don't know.
I think it's a rectangle.
Rectangle. Yep. Remember. Let's just so I can listen to us. How many? 12. Ooh, I wonder how many I have.
I have one.
Let's see. He has 12. I wonder if we all have the same. 3, 4, 5, 6, 7, 15. It's snack time, so you can eat it. Yes, you're right. 15. Take away 1 makes 14. 14, 15, 16, and 1 that I bit. So 17. 17. But if I ate this one, 17 minus 1.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
How did you make 17?
So I took these 3.
You added 3.
Yeah.
You put 3. So when we add, we're putting more.
I mean 5 and 5 equals 20.
Let's try. 5 plus 5. You put 5. No, that's 10. But that's 10. You said 5 plus 5, and then you put up 5. Okay, so how much is that?
20.
Let's count. Ready? 1, 2, 3. Don't count yours yet. Oh, you want to count yours first? Okay, count yours first.
2, 3, 4, 5.
6, 7, 8, 9, 10. Count with me. 11, 12, 13, 14, 15. What was it? 5 plus 5 plus 5 equals 15, yeah. But if you add your other 5, then that is 5.
Yeah, that's what I was trying to do.
It'll be 5 plus 5 plus 5 plus 5.
All right. And so just in the chat, or if you want to unmute yourself and share anything you noticed about the way the children were engaging in addition and subtraction, and then also the way that the educator was supporting them. And so you can drop it in the chat, you can unmute your mic, totally up to you, but anything that you noticed again about how children were engaging in addition and subtraction.
This is something that I usually tell the parents that, there's always an opportunity to do math everywhere you go, regardless of what you're doing. Right. So, I just started my parent workshops. That's why I missed my coaching session because I was in a meeting doing all those details. And so we started talking about, the opportunities, the window of opportunities that we have. And so we decided that within our program, we're going to give them a 30-minute for them to socialize, but also to sit with the kid and do open-ended questions, do some kind of math activity. And this is, a simple one that, with the snacks, they're talking about it, they can even, do the counting, they can even do um, touching it, doing all 5 senses right there, talking about description, maybe even shapes, what kind of shape is the cracker. So there's always, I guess, like a few minutes for us to, put all those, especially math um, activities without even knowing that they're doing math.
That's the best part, right? They don't realize that they're learning. They don't even realize it. They're engaged. They were excited. They were looking forward to eating their crackers or their cookies. And like you said, using these windows, I love how you said using these windows of opportunities, right? To engage in math concepts like adding and subtracting, and refining their counting skills, right? So using any opportunity we get, right, as parents, as caregivers to support our children with mathematical thinking. Yes.
One of the things that I like about the video for the teacher is that she allowed them to use whatever technique they wanted to use. Once they were making groups like lines of tens, another ones was separated by fives, and other ones was eating and counting one by one. So I love it. I love how she approached every moment and be successful making the with the kids the connection for the math and adding and subtracting at the same time.
Yeah, you're absolutely right, Laura. Thank you so much for sharing your observations. Yes, and thinking of how much more engaging this is, right, than traditional pencil to paper activity, right? And so hands-on, tapping into the different senses. It feels like they're playing, right? They're also eating and snacking away, but as they're snacking away, like you said, Laura, oh, now I ate what? Now I only have 15 left, right? Or what was it that the girl said? And so, yes, thank you both so much for sharing your observations. Veronica, from you, I take away the using the windows of opportunities, right? Laura, from you, I take away the teacher letting children explore, right, through different ways and highlighting how adding and subtracting can look different for everybody, right? And each child was engaging in different strategies. Good. Thank you so much. All right. And so now let's move to our next slide, right? And think about different ways, right, that children engage in adding and subtraction to solve problems of interest, right? And so we saw a little bit of that in the video now. And so again, using these windows of opportunity, right? Children can learn about addition and subtraction as part of their everyday daily interactions, right? And especially when play is involved, or when we create opportunities for play, right? Through which they're also working on adding and subtraction to solve problems of interest, right? And so, for example, children might add or subtract when engaging in eating a snack, which is the video that we all just saw, right? Or prepping for a meal. And so children might do things like, I don't know, subtract to figure out how many cookies they have left or how many orange slices they have left after they ate some, right? Or shared some with their friends. They might also engage in adding or subtracting when engaging in pretend play, right? And so we see this often in play centers with a cashier, right? Children might add to find out how much pretend money they have, or how much pretend money their customer needs to buy something in their pretend cafe, right? And then children also engage in adding and subtraction through games, right? Or through board games. And so children might want to add points to determine who won the game, right? Or by how many points someone won the game, whatever game it is they're playing. Children might also engage in adding and subtraction when exploring outside, right? And so children might collect and sort things like rocks or leaves or just any other thing they could find outside, right? I remember I had a student who loved collecting roly-polies, and so he would come back to the classroom and would say, like, "Teacher, I have," he would put his hand in his pocket and say, like, "Teacher, I have 4 roly-polies," right? And I would say, "Okay, let's take them back. If we put 2 back, how many do we have?" And eventually he had to go put them all back, right? But he was outside, and he loved roly-polies, and he loved finding them, right? And so tapping into those opportunities and those interests of our younger children, right? So that they're engaging in math, in not only in math, right, but in specifically in adding and subtracting. And so addition and subtraction experiences, right, that are part of our students' daily interactions and builds on their interests. They enhance engagement, right? Students are engaged, and they allow children to also physically manipulate objects, right? And explore objects. And they can see, and it's hands-on when quantities change, right? And so when something makes more, when something makes less, it becomes tangible for them. And so this deepens, right, children's understandings of these math concepts. And so again, throughout our session, we'll explore ways that educators can use these authentic and daily experiences, right, and concrete objects and manipulatives to support children to add and subtract in ways that are most effective for our younger learners. All right. And so now we're going to talk about how children, right, beginning in pre-K up to second grade, begin to understand and continue to develop their understanding of addition and subtraction. And so first we're going to begin by reviewing how addition and subtraction is described in the preschool transitional, or TK, learning foundations, right? And so there are 3 pre-K TK foundations that describe what children learn about addition and subtraction. And so those foundations are within strand 2, right? Operations and algebraic thinking, and within the substrand number and operations. And so these foundations, what they do is describe the children's ability to demonstrate that children can engage in adding, right? And they understand that adding makes more and that taking away makes less. They're also engaging in that numbers can be put together, right? So they can be composed or put together and also taken apart or decomposed. And they're also engaging in understanding that there are different ways and different strategies to solve addition and subtraction problems. And so in your participant folder, I uploaded this document, right? And it's, you have the pre-K, TK learning foundations, the entire math document in your participant folder, but I also uploaded just the strand 2 operations and algebraic thinking, right, which includes the substrand number and operation specifically for this session. If you want to take a look at it, I just put the link in the chat. And so moving on from pre-K and TK, right? Now we're looking at kindergarten. And so now we're going to review how addition and subtraction is represented specifically in the California Common Core State Standards, right? And there's a variety of kindergarten standards that describe what children learn about addition and subtraction. And for kindergarten, these standards fall under the operations and algebraic thinking strand, right? And this describes the ability of children to solve word problems, right? And so the way that they're solving word problems is by using a variety of materials, right, and strategies. And so, for example, within this standard, right, it highlights strategies like counting on, right, or making 10 and other decomposition strategies. Under operations and algebraic thinking kindergarten standards, right, students are also solving problems within 20. And so they start demonstrating greater fluency within 10, but of course, solve problems up to or within 20. Also, right, under this standard is students start expressing their addition and subtraction using written equations, right? And so this is the first time we see, right, the use of written equations. Now, under the number and operations in base 10 strand, right, this includes a standard related to addition and subtraction. And so what this one does, it describes how children begin to understand place value, right, by again composing and decomposing two-digit numbers. And so, for example, children in kindergarten begin to understand that 11, right, is composed of 10 and 1. And so I'm going to link in the chat for you, right? It's kinder through second, but what I did is took only the kinder through second math standards and uploaded it in the participant folder for you if you want to access and if that's helpful. All right. Now, when moving on from kinder, right, and looking at first and second grade standards, there are several key standards that describe what children learn about addition and subtraction. And again, the standards under the operations and algebraic thinking strand describe children's ability to solve addition and subtraction problems. And these standards describe the children's ability to do a couple of things, right? The first is continue the focus on word problems, right? And so they're continuing to solve word problems with unknowns in all positions, right? And so they'll do this by using a variety of strategies and materials or manipulatives. In first and second grade, right, they'll demonstrate greater fluency with addition and subtraction and within 20 by second grade. They're continuing to work on solving word problems as equations. Remember, this was first introduced in kinder. And then first and second graders are also applying properties of addition and subtraction when solving problems, right? And this happens by the end of first grade. And additionally, right, the standards under the number and operations in base 10 strand, they describe children's understanding of place value and how it relates to composing and decomposing two-digit numbers, right? And so for this, it's important to remember that children, right, across diverse communities develop understanding in different ways and at different times. And so this is where we think about children's cultural and linguistic backgrounds, right? And how that can help guide us as to how we support children with developing addition and subtraction skills, right? And so while the standards provide us with meaningful goals, right, that guide us to support children in building mathematical knowledge and skills, we as educators can use what we know about children's backgrounds, right, to provide more responsive support for math learning. And so just thinking of how we can also make our instruction culturally relevant and responsive to the very specific needs and backgrounds of the children we serve. All right. And so we are going to continue by reviewing what children understand about addition and subtraction, right? And we're going to think about children from infancy, right, into early elementary and how they develop an understanding of math concepts such as that adding makes more, right? Or that taking away makes less. That again, that numbers can be put together, composed, or taken apart, decomposed, that numbers can be added in any order, right? And we'll see this as a commutative property later. And that addition and subtractions are opposites. And so thinking about inverse. And so when looking specifically at adding makes more and taking away makes less, right? We understand that infants and toddlers understand this, right? At their very young age. And so in preschool, children can begin to communicate more accurately about the changes in quantity because now they can use number words, right? And so, for example, they can say the number 3, right? Or they can also use gestures. For example, they can hold up 3 fingers, right? And just keep in mind, right, that they might communicate using their home language, right? If they're able to do that in English, or they may communicate their number knowledge using a mixture of both their languages, right? Um, and so, as children explore the concepts of adding more and taking away, and as they solve addition and subtraction problems during daily routines and playful experiences, right? Educators, for example, might support children doing this through or when they're reading books, right? And so, a lot of the times, I know we think of our read aloud time as strictly literacy time, but remember, we have to think of ways where we can bridge in supporting children's mathematical development, right? And how we can also connect that through literacy. And so just an example of the book, right, that lends itself well to adding and subtraction is Pete the Cat's and His Four Groovy Buttons, right, by author Eric Litwin. And so children might make predictions about how many buttons Pete, right, has left after he loses some. And so children, by doing this, right, they'll understand that losing a button means that there will be fewer buttons, right? And they might be able to communicate a quantity that is less, right, than what he had before, or the buttons that Pete the Cat began with. When you saw during mealtime, right, when adding crackers to their plate, or items to their any other food item to their plate, right, children will understand that this results in more, and they might predict how many they have in all. I remember when I was a kindergarten teacher, I used to love using goldfish because kids love goldfish, and this just got them super engaged with adding and subtracting, right? And so just again, finding ways to support developing their conceptual understanding, right? That adding makes more and taking away makes less, to things that children can connect with. Now looking at different ways to make 10, right? And so we just in the previous slide reviewed the concept, right, that adding makes more and that taking away makes less. And so now I want us as a group to explore a different concept that is part of adding and subtracting. And so I didn't ask you to collect any materials for today's session because I wanted us to try to use whatever was available and within our reach. But if you at your desk right now or wherever you're sitting at, right, can find a way to make 5. Find a way to make 5. And so whatever you have, let me see, at your desk right now, find a way to make 5. And I'll give you just a couple seconds. So anything, oh, I see Denise putting up she has her highlighters up. Elizabeth has all her notebooks up. Oh, forks. Nice. I see the reusable forks. I use my daughter's buttons. She has like these cool buttons here that she just left on my desk. And so I have 3 of the buttons And then I was wearing accessories. I was wearing 2 rings. And so I just took off my rings. And with my 2 rings and my 3 buttons, I made 5, right? And so what we did, right, was ourselves engage in finding different ways to make a number. Now on the screen, I know you see a set of 10, but because we're in our table, I lowered that number to 5, right? But through this activity, right, we just explored the ideas that numbers can be put together and taken apart, like I had my 3 buttons and my 2 rings. And so sets of objects, right, can be combined to create a set of something, right? Now for this activity on the screen, you see 10, I asked you to do 5. But similarly, right, a group of 10 objects or 5 objects can be broken apart, right, into smaller sets and different ways. And so thank you all so much for making your set of 5 and participating with that, right? And so when thinking of number composition, right, this is when children combine 2 sets of objects to make a larger set. And so in preschool, children begin to explore the idea, again, that numbers can be put together and taken apart. And so children can combine 2 sets of objects to make a larger set. And through through these experiences, right, of combining sets, they learn about number composition, right? And so, for example, children learn that 3 apples and 2 apples can be combined to make a set of 5, right? Or that 3 buttons and 2 rings can be combined to make a set of 5 objects. And et cetera, et cetera. Elizabeth showed her notebooks, or that 3 notebooks, right, and 2 other Post-its can be combined to make a set of 5. Now that was number composition, right? Now number decomposition, right, is when children break numbers into smaller sets of numbers. And so in preschool, children can also explore ways to break up a larger set into smaller sets, right? And so through doing this, they build an understanding that there are many different ways to decompose numbers, right? Or break larger sets into smaller sets. And so on the screen, I love this template because it takes like 3 seconds, right, to make this template where children can begin to explore this concept. And so, for example, if a child begins with 4 rocks, right, they can break that set of 4 rocks and break it into either a set of 2 rocks, right, with each set having 2 rocks, or they can do 3 and 1, right? And so through this, children begin to explore again, breaking up numbers into smaller sets of numbers. All right. Now, by the ages of 4 and 5, right, children typically can decompose numbers less than 5 into smaller sets of numbers in more than one way. And so, for example, we just saw the rocks, right? But in the one you're seeing here, 4 leaves can be decomposed into into 2 sets of 2 leaves, right? Or 4 leaves can also be decomposed by having a set of 3 leaves and 1 set of 1 leaf, right? And so again, ages 4 and 5, children typically, right, can engage in decomposing numbers that are less than 5 into smaller numbers in more than one way. Now, by the end of kindergarten, right, children typically begin to decompose numbers that are less than 10, right, into sets in more ways than one. And so by the end of kindergarten, right, we should see children decomposing 10 in different ways. And so making a set of 7, or making a set of 3, or making a set of 5 and 5, right? Or finding different ways to decompose a number 10. Now, it is important for me to highlight that solving problems, right, that involve composing and decomposing numbers is way more meaningful for our younger children when the problems are related to their daily lives, right, or when they have objects that they can manipulate. right? And so just thinking about how can we support our children in having these hands-on play-based experiences, right? And thinking also again about their cultural background or diverse experiences, right? And how can we offer and create these opportunities for them with things that are meaningful to them, right? Or are going to engage them. And so just thinking of ways, right, to make learning about subtraction and addition, right, relevant and engaging for children. Now, as children, right, learn to count beyond 10 and have experiences of composing and decomposing numbers, right, in kinder, their understanding will grow, right, and they'll begin now to understand that numbers beyond or between 10 and 20 are composed of tens and ones, right? And so by the end of kindergarten, the goal is for children to be able to compose and decompose numbers from 11 to 19 into tens and ones using objects, drawings, or equations, right? And so, for example, a set of 10 gray rocks and a set of 2 white rocks can be composed by making a set of 10, right? And 2 for a total of 12 rocks. Or just another example, right? 15 can be decomposed in a set of 10 and a set of 5. And so composing and decomposing using tens and ones really, this is so important because this really sets the foundation for children to begin to understand place value, right? And the base 10 number system. And again, this happens in first and second grade. And so, for example, children will understand that the 1 in the 2-digit numeral 12, right, represents a 10, and that the 2 represents 2 ones, right? And then that both of those 10 and 2 can be then composed to make the number 12. And so another example, right, of composing and decomposing numbers and how this supports understanding the place value system. And again, just highlighting that this is not just about memorizing numbers, right? But the hope is that by the end of second grade, students extend their understanding, right, into the hundreds. And so now by the end of second grade, they'll learn that 100 is a bundle of 10 tens, right? And that 3-digit numbers are made up of hundreds, tens, and ones. And so instead of seeing, for example, the number 345 as just digits, they should understand that the 3 represents 300s, the 4 represents 4 tens, and the 5 ones. And so what this does, it builds a strong number sense, right, and sets the foundation for future math like addition and subtraction because students can then break apart and recombine these numbers with a lot more flexibility. And so now, right, I don't know if that image looked familiar to you all, but when supporting classrooms, I see these a lot during calendar time. And so now I want us to watch a quick video about how this teacher, right, reinforces place value knowledge during her calendar routine.
Or are we gonna
Ready?
keep switching?
Calendar. I'm really focusing on the tenness and oneness right now, and eventually we're going to do hundreds. But, you know, like we have a number, and I say how many more to make the next 10. How many days have we been in school? How many? Let's count them. 10, 20, 30, 40, 50 plus.
51.
Show me with your fingers. How many days to 60? Show me. How many days to 60? So what's our combination? It's 1 and
9.
1 and 9 makes a 10. Good job.
All right. So super quick video, right? That the teacher uses during her calendar time to reinforce the concept or have students at least engage with the concept of place value, right? And what better way to do that than counting the days of the school or counting the days of school you have left before summer break, right? That one's always a favorite. But I really loved how she incorporated, right? And we heard some of that language that she uses when she asked them to add 50 and 1. 1 and she said, what's our, I think she said combination, right? And the students were able to do it. Then she still asked them how many more before we make another 10. So a lot of mathematical skills going on right during this calendar activity. I also really like how she had visuals, right? And the visual or the slide deck was interactive and she was updating it, right, with student feedback. All right. Let me see if I can. Okay, there it goes. Now, when thinking about how we support our younger learners, right, with composing and decomposing numbers, and making it hands-on, right, and making it engaging for them, I wanted to share this handout with you all. So I'm going to give you just a few minutes to open it. And you on your own can look through the document as I explain the activity, right? But what it is, it's a game called Animal Islands, right? And so again, just thinking of ways that we can support children's understanding of addition and subtraction through meaningful investigations and activities that'll encourage our children, right, to add and subtract in different ways. And so this activity can help us do that, right? And so what it is that you create an animal island. Now you could do this by using like two baskets, or I even like using two just papers where children will draw an island, right? And so you have island A or island B. And then the children create boats because the numbers or the objects, right, have to get from one island to another, and they have to use both boats. And so the image that you see on the screen, right, is the animals or animal islands, is that the children broke up a set of 5, right, and they broke it up into 3 and 2. And so the animals are going from one island to another, and so from point A to point B in their two boats. And so what this does is just provide an opportunity for children to explore the different ways that the animals can get to the other island, right? Now they can all go on one boat, they can go 4 and 1, they can go 2 and 2, right? And you can add or decrease the number of the quantity, right? Or the quantity of the animals moving from one island to another. The islands, what they look like, you can have a basket where they land, but also, like I said, one of my favorites that I've seen is just a sheet of paper where children will design their own island and they'll draw their island. And so they'll get super creative and they'll say, I went from Candy Island to like, I don't know, Volcano Island, right? And they'll draw. And so this makes it engaging, it makes it fun for students, all while they're exploring, right, composing and decomposing numbers. And so just thinking of ways, right, where we can create opportunities for students learning to be hands-on, to be fun. They think it's a game, right? It is a game, but through which they're learning and reinforcing, right, their composing and decomposing skills. And so just that one was a fun one to share with you, right? Also very low prep, right? And engaging for children. And again, thinking always, right? How do I move toward designing more meaningful opportunities for my students to develop their adding and subtracting skills. All right. And so now I want us to move on to properties of addition and subtraction, right? And so as our children get older and they begin to deepen their understanding of number composition and decomposition, they'll also develop a deeper understanding of addition and subtraction, right? And so typically, right, by early elementary grades, students will develop an understanding of these 3 properties of addition and subtraction, right? And we all know them: commutative property, associative property, and then inverse property. And so now I want us to explore some of those properties ourselves. And you could put it in the chat, but it's time for us to also do some adding. And so 57 plus 48. And so if you can solve it, and you can solve it any way you prefer, just drop the answer in the chat. Does anyone know the answer? 105. Thank you so much. Thank you so much, Alejandra. Yes, 105. And so just out of curiosity, how did you solve it? What was your brain thinking as you were solving it?
I took 3 from the 48 to make 60, and then I just did 60 plus 40 and then plus 5, which was the number that was left.
Nice. Thank you so much, Alejandra. Anyone else do it a different way?
Yeah, I added a 5 and a 4, that's a 9, and then 8 plus 7, 15, so 105.
Good. Thank you so much, Veronica. Denise, is that kind of what you did? I saw you shaking your head.
I did the opposite of Alejandra. I took 2 from 57 and made 50.
Oh, I see 2 from 57 and made 50, and then you added the 55. Yeah.
Mm-hmm.
Good. So all different strategies, right? And you all landed at the right answer. Laura, what did you do?
think I use the regular way because I just see, okay, 7, 8 is almost there. So I take 1 from the 8, so it's 5. And then that added to the 4, so that's 10, oh, 10, 5.
Yeah, good, good. So everyone used a different strategy. That's that's so interesting. So everyone's brains work differently, right? Everyone's brains work differently. So thank you so much for sharing the ways in which you solve that. Now let's solve a different subtraction problem. Now we're self-solving the one at the bottom. Now what's 48 plus 57?
105.
105.
105. Yeah, right. And so that one's obvious, right? And well, it's obvious to us, right, as adults, but we knew the answer very quickly, right? Because we understand that the order of numbers being added, well, doesn't matter, right? And so the order of the addends won't change the answer. It doesn't matter. And so what this is a commutative property, right? And so 5748 will give you the same answer as 48 and
You
57.
make me
But you know
hesitate.
what?
Yeah, you make me hesitate because I heard you. Okay, now let's do this. The next subtraction. I was like, what the heck is
Oh, I'm
that?
sorry. Did I say subtraction? I threw you off. I'm
Yeah.
sorry.
No, but you know what? It also for me, I have a hard time adding my numbers horizontally because I'm so
Oh,
used to 50 and then put the 7 under and the 43 under and the 5. So
that, yeah.
column wise.
Which I think speaks to the way that we were taught math, right? And so before Common Core math, that's the way we were all taught to do it, right? And so just following the steps. But you're right, Veronica. I agree with you. That happens to me too. I have to think about it for a little longer than I think I should. Than I should. All right. And so now let's explore adding more numbers. And so now we're exploring another property of addition, right? That's related to the idea that the order in which numbers are added doesn't matter. And so solve it using any strategy you want, but can we add 50 plus 7 plus 43 plus 5? Yay, the same one,
105.
right? 105. And so you might have used again different strategies to come to that answer. Like, did anyone just add from left to right? What did you do this time around?
I went for the middle. 7 plus 43, so it's 50, the other 50, and then the 5. So
And then 5, yes. And now that you say it, that makes the most sense to me, right? I
The
think
chunk
everybody,
method.
yes, the chunk method, right? Yes. Make sense wherever possible. But yes, thank you for sharing, Laura, right? And so what happened there, right? And this explains it just like you did, Laura, was that you all just experienced the associative property of addition, right? And so the associative property of addition means that numbers can be added in any order or any grouping, right? And so, for example, students in second grade are more likely to have fluency in different ways to compose 10. And so they're likely to know that 3 and 7 makes 10, right, Laura? And so they would add or gravitate toward adding the 43 and the 7 first, right? And then continue to add the 50 and then the 5. The associative property is strongly related to the commutative property of addition, right? And so just highlighting that when children understand the associative property, they can group numbers in any way that will help them solve the problem in the most efficient way, right? I always tell my daughter this, like, think of what's going to make it easy for you. What's going to make it easy for you? And find those patterns. All right. Next one. And so now we're going to continue to explore one more property of addition and subtraction, right? And so here's the same equation that we've been working on. The 57 plus 48 equals 105. And so now the new equation is 105 minus 57. What is the answer? And you could use any
48.
strategy you prefer. Yes, 48. Laura, how'd you do it so quickly?
I just take the other one.
You just took the
Just
other
which one?
number, right? Yes, you're absolutely right. And so what you just did, Laura, right, is the inverse property of addition and subtraction. And so what that is the idea that addition and subtraction are opposites, right? And so, for example, we knew that 57 and 48 make 105. Therefore, we could easily figure out that if we take 57 away from the 105, right, the part that remains is that 48. Thank you,
That
Laura.
explains why I had a hard time in algebra. Because I had understood the inverse for a while.
It's complicated. It's complicated, right? And it takes a lot of practice. And I think what helps understand this is building that conceptual understanding first and understanding, right, that when you're adding, you're putting two parts together to make a bigger part, right? And so I think having that strong foundation really helps for understanding the inverse property of addition and
But I
subtraction.
think it goes back to the way we were taught all these basic concepts. Because I had a hard time. Nobody told me, which nobody explained to me, I guess I should say, that, multiplication was just a quicker way of addition, right? Until like now, and I was studying to be a teacher, so I had to learn all the theory behind it. I'm like, how come nobody told me that?
Yes,
Nobody
yes.
said it to me in those terms. I'm like, oh, I knew that I had to memorize them, but I'm like, but wow, until later it's like, okay, now I know.
Now it makes sense. And I think you're absolutely right, Veronica. It speaks to the way that we were taught. We were taught through rote memorization or through following a procedure, following an algorithm, and these are the steps, right? And this is what you do, but we never really had access or understood why. Like, I'll never forget that when I was doing my student teaching, I did it in a fifth grade class, and I had to do a unit on division, and I knew how to solve division, right, using just the steps, right? And I went through the process, but it wasn't until I had to teach it that I understood, oh, this is what's happening, right? This is what I'm doing. Before it was like, oh, just place a zero, and I knew to place a zero, for example, but I didn't understand what that meant or what that represented, right? And so again, it now, right, we understand that it's a lot more important for students to develop a strong conceptual understanding and not rely solely on memorization, right? I think I've shared with this before in the first meeting, but I remember being in early in early elementary grades, right, and sharing that I was really good at math. I'm good at math. I'm good at math, right? What I think I was good at was memorizing, right? I had a good memory and I was able to memorize facts and I like knew all my multiplication facts before anybody in the class, but I didn't understand what it meant. I was just able to repeat and memorize, right? And so just different ways of doing things now, right? All right. And
And also
so
the
now,
motivation. I had to memorize everything because I didn't want my teachers to use the ruler on me.
oh no. Yes, well, I remember we had a chart where we tracked multiplication facts, and like the students who made progress got a star, and the students who didn't, and it was exposed in front of the whole classroom, right? And so you can see who was making progress and who wasn't. And I remember being scared, or not being scared, but feeling like I don't want everybody to know that I'm not I'm not making the progress that I am, right? And so I remember like studying my flashcards and memorizing my multiplication facts because of that, right? But I don't know what 5 times 7 is, right now. Like I have to think about it for a second. I have to think about it for a second. All right. And so now, right, children then, right, begin to or come to understand the properties of addition and subtraction, and they'll learn about properties of addition and subtraction through different avenues, right? And that's through experimentation with concrete objects, right, which is essential, through experiences with composing and decomposing numbers in different ways, and then using number bonds or these fact families, right? Um, and so again, some children learn about these relationships through these fact families. And what they are is a collection of math facts that show the relationship between the same set of numbers, right? And so educators might encourage children to represent fact families using these number bonds, as what you see on the screen. And
Natalie,
so,
until you're explaining it right now, my husband, he always has a little game with my kids where he's done like kind of a memorizing, but whatever. He was like, okay, what is 2 plus 2? And they are 4. Okay, how much is 2 times 2? Oh, 4. Okay, so how much is 2 elevated to the 2, to the, ¿cómo se dice? Al cuadrado, right? In Spanish. So they were like 4. Okay, so what is the root of 4? 2. Okay, how much is 4 minus 2? 2. So they were playing around with the numbers, and I was like, they are kids. They are like 3, 2 years old, and they were able to answer through the game to him. So now I understand that there are a whole bunch of numbers that, as you were saying in here, that they can play with. And
yes.
I was clueless about this until now.
Yeah. Yes, you're right, Laura. And so what number bonds are, right, is that they can help children, right, understand how two smaller numbers are a part of a total or a whole. And so, for example, children might make a number bond using 8 as a whole, right? But then part of that can be a 3 and a 5, right? And so then children can understand that then 3 plus 5, they'll understand how 3 plus 5 are related to 8, right? Or that 5 plus 3 also equals 8. And so again, just the order in which the numbers are added won't change the answer. And they begin to understand this, right, through the use of number bonds. And so something else that children can do is notice that 3 and 5, for example, are both parts of a whole. And if one of those parts is removed, right, for example, if you do like a minus 3, or if you do minus the part that is 3, right, the remaining part will be 5. Or that when we combine the two part, right, those two parts will make a whole, which in this case is 8. And so by doing that, they're understanding the inverse property. And so educators can also present problems that illustrate these principles, right, after each other to help children realize through inquiry, through exploration, that although problems might be different, they are related and will sometimes share the same answer, right? And so, for example, we teachers might want to present 3 items that appeal to children and ask the children to add 5 more and solve for 3 plus 5. And then educators can ask the children to now take away 3, solving for a minus 3. And so I want to ask children, right, what patterns do you notice? Or what are you seeing? What are you observing, right? All of this to highlight the inverse relationship between the equations. All right. And so now, right, we've discussed key understandings that children can develop about addition and subtraction, right? And so now I also want us to examine different strategies that children might use to solve for addition and subtraction problems, right? And these do include counting, using your fingers, right? Composing, decomposing, and using properties of addition and subtraction, or building on the known facts, right? And so we're going to focus on children's use of counting strategies, right? All right. And so the first one we're looking at is that children, right, use different counting strategies when learning how to add and subtract. And they might use counting all of the objects, right, that they see. They might use counting on, or they might even use counting down strategies. And so counting all and counting on in addition, right? And so the count all strategy is typically the very first one that we see children use when adding and subtracting numbers, right? And so what that is that children will combine two sets of objects and then count them all to find how many there are in total or in all. And so a quick example, if a child has a set of 5 blue sticks and a set of 6 red sticks, they'll put those sets together, right? And the children might begin counting the blue sticks and start from the number 1, 1, 2, 3, 4, 5, and then count on until they count the total of sticks, right? And so to add those sets, the child might physically push the two sets together, right? And count them all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 until they count all of the objects in that set. Now, as children get more practice with counting, more comfortable with counting and adding and subtracting, they might use counting on strategies, right? And so this means that they'll start counting from one of the add-ins. And so one of the numbers in the addition problem, and then they'll count up, right, from that number to find the new total. And so, for example, if a child counts the first sets of blue sticks, 1, 2, 3, 4, 5, right, and then they add 6 more, they won't begin counting at 1, right? They'll begin counting from the 6 till they get to the last object. And so they won't start from the beginning and go 1, 2, 3, 4, 5. They know that there's 5, right? And so now they'll start counting forward or on from the 6 until they get to the 11, right? And so that's what we see on the right-hand side of the screen there. And so counting on is a more advanced strategy, right? Because it does require that children start counting from a number other than 1. And since the beginning, from pre-K, right, we've been counting starting with the number 1. And so this can sometimes be challenging for some students. And so it is a bit of a more complex skill, right? But again, as children gain more confidence, become more comfortable with the counting sequence, right? You'll typically see children make the transition from counting all to counting on around kindergarten, right? Or might happen even sooner in TK. We also want to want to consider that children might count in their home language, right, or in a language other than English or both. And so also just thinking of our multilingual learners and how we support children to use the language that is most effective for them when they're either counting all or counting on, right? And so do not discourage the use of home language, right? We should be supporting our children in using their home language and whatever language is more helpful for them, right? In counting on or counting all. Now counting on from larger, right? And so this is when children start getting a little more strategic with counting on, and they'll count on from the larger number, right? And so they'll eventually discover this, but of course we can support them in doing that, right? And this is related to the commutative property. And so children understand that the order in which you add doesn't matter, right? And so they'll start counting from the larger number. And so for example, if they're adding 9 plus 2, right, or a group of 9 sticks to a group of 2, they won't they won't say 2, 3, 4, 5, 6. They won't start from the 2. They'll recognize that 9 is a larger number, right? And that they can find the answer faster if they start from the larger number, right? And so now they'll say 9, right? Begin with the number in the last number in that set and then count on 10, 11, right? And so counting on, and then it gets a little more strategic with counting on from the larger number. All right. Now, counting all and counting down with subtraction, right? And so children will start using similar counting strategies to also solve subtraction problems, right? And they might use a counting all strategy, and they'll count a total number that's in the set, counting the items taken that's out of that are taken out of the set, and then counting all the remaining ones to figure out how many are left, right? And so, for example, if we use the example of 7, take away 3, right? A child counts a set of 6 to determine that, yes, there are in fact 7 sticks, right? Then a child might remove the 3 sticks, 1, 2, 3, remove those, and then counts a set again to learn that taking 3 away from a set of 7 will result in 4, right? Or that there are 4 left. Now, another strategy that children might use to subtract is counting down strategy. And so this means that a child will start with at the number and then count backward, right, by the number that is being subtracted. And so we're taking the 7 take away 3 again, right? Children will count down starting at 7 and say 7, 6, 5, and then say 4, right? So they can do something like this: 7, 7, 6, 5, right? And then determine that there are 4 left. Oh, that was a little bit challenging for me. Now, it does take time and a lot of practice for children or adults to comfortably transition from counting all to counting down, right? But some children will make the transition in preschool, right? While others may make this transition later in kindergarten or in first grade. And then some children might discover this strategy on their own, right? As they alone explore adding and subtracting. And other students, right, might benefit from more explicit teaching and support from educators and or their families or caregivers. Right. Now looking at some more advanced counting strategies, right? And so children they'll continue to use their count all strategies, right? Even when they start using larger numbers, but they might use skip counting, right? Instead, or to help support them and do this more quickly. And so, for example, a child might add 30 and 55 by skip counting and do something like 10, 20, 30, 40, 50, 60, 70, 80, 85, right? Or a child might use a counting on strategy, and a child who understands a commutative property, right? The idea that order in which you add doesn't matter, might realize that adding 55 to that set of 30 is the same thing as adding 30 to a set of 55, and they might start counting up from the larger number, right? And so, for example, they might say 55 and then count on 65, 75, 85. Counting on can be challenging for children because it requires them to start counting from numbers more than 1, right? So still challenging when thinking of counting from a number that doesn't begin with 1, or when using, again, skip counting. All right. Now, counting strategies for subtracting. Right, counting down, children will start at the total and then count backward. We reviewed this a bit, so I won't take too much time on this slide. Or counting up to the total. Children will start at one of the parts and then count up to the total. This one is a little challenging, right? Because it requires children to know how to, well, this one, the counting backward run, right? So the counting down can be challenging because it requires students to know how to count backward and then hold in memory how many fingers or objects are moving, right? And so there's multiple skills going on there. And so children can use things like number lines to support counting down as a strategy for subtraction. And then the other one, the counting up to the total, some children might use this strategy, right? Counting up to the total to solve subtraction problems. And this happens when children begin to understand that part whole relationship, right? And how that relationships relates to addition and subtraction. And so, for example, if solving 8 minus 3, right, a children might understand that the total is 8. that one part is 3, and they might use addition to count on from 3. For example, 3, 4, 5, 6, 7, 8, right? They're counting up to the total. I've gotten to 8. That means that my missing part was 5, right? And that's how they realized the missing part was 5. That's understanding, right, of part-whole relationships. And so again, just thinking of different ways that we can support students compose and decompose numbers in different ways. It does take a lot of time and practice for children to transition to comfortably transition from counting all, right, to counting on or counting down strategies, right? And again, just thinking of different developmental stages, right? Some children might make that transition on their own. They might make it in kindergarten, while others may make it in first grade, and while other students might benefit from more explicit instruction around those skills. All right. And so continuing to think about composing and decomposing to solve addition or subtraction problems, children will deepen their understanding of number relationships, right, and the properties of addition and subtraction, and they'll become more flexible in how they solve problems, right? And so, for example, they can decompose or compose numbers in different ways, and we all just saw you do that earlier in that activity with adding and subtracting. And then they'll decide, right, what numbers does it make more sense to add first, right? And so we can look at what might make more sense when we're adding numbers like 17 and 8. And so one example that children might do is that first, right, they might know or they'll understand that from 17 you need 3 to make 20, right? And so they'll decompose the 8 into 3 and 5, and they'll do 17 plus 3, easy, 20, right? And then they'll just add the 5, and that makes 25. And so again, just thinking that children will get more comfortable in the strategies that they use, right? And they'll be able to be more flexible in the way they solve problems. And this approach to solving addition or subtraction problems, again, we talked about this earlier, might seem different than what we learned, right? Or how we learned to add and subtract when we ourselves were in school, right? And again, some of those older methods of teaching students how to add and subtract, they had a huge focus on arriving at the correct answer, right? And that was very important. And it typically involved using a series of steps, right? For example, we talked about adding in columns, right? Or using the algorithm. We're moving away from that now, right? Understanding that conceptual understanding is a lot more important. And so just, right, thinking of some ways that children are taught to solve addition and subtraction problems today, right, moves away from that rote memorization of steps, right? And so instead, moving toward a focus of students having a good, right, strong foundational understanding of what is, right, addition and subtraction. All right. Now, another way, right? Yet another way that students might solve addition and subtraction problems is by building on facts that they know that they're comfortable with, right? And so these known facts or answers to addition and subtraction problems that children have constructed just from their previous experiences can be used to solve other problems. And so, for example, from memory, right, children might know addends that equal to 10. And so they know quickly, right? 8 plus 2, 6 plus 4, 7 plus 3, 5 plus 5. Or they might know by memorizing doubles, right? Just from repeated practice. They might know the answer to 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, and so on. And so children will use these facts of doubles, for example, to solve problems. And so, for example, when solving an equation like 6 plus 7, children might right away know 6 plus 6 is 12. Then they'll just add the 1. I do this one all the time, especially with multiplication. I know my like 7 times 7, 6 times 6, and I'll have to rely on that, right, to solve multiplication problems or when helping my daughter with her homework. And so to come to know facts, right, young children can draw from meaningful and diverse experiences with addition and subtraction. And again, thinking about experiences both in the home and school context, right, that will help them solve a variety of addition and subtraction problems in different ways and across different contexts. And if children memorize addition or subtraction facts, right, without understanding the relationship between the numbers, this is where things get complicated. Now, a child might understand again that 5 plus 5 is 10, 6 plus 6 is 12. But what's important there, right, is that they also have, right, a strong understanding of the relationship between the numbers. And so again, just thinking of simply or only focusing on rote memorization tasks, right, is when we see that children will then often later in life, right, struggle to apply those facts to new or more complex problems, right? However, when children are encouraged to find patterns and in their reasoning and build understanding of how these numbers work together, right, and the relationship between them, this is when remembering facts is helpful and useful, right, because then they can apply them in a more flexible and useful way. And so just again, it's important to learn about children's abilities, about their prior knowledge, right? So that we're able to best support them in their ability to use these known facts or as a way to solving addition and subtraction problems. All right. And so we reviewed different strategies, right, that children might use to add and subtract. And as children gain more experience in using these different strategies, they'll adjust their strategies, right? They won't always rely on the same one. It'll depend on the problem that they're trying to solve. And so children explore many different types of problems using addition and subtraction. And so just some examples are, right, when the end is unknown. And so going back to those word problems and thinking, in thinking of them into these three categories, right? And the first one is when the end is unknown. And in end unknown problems, right, the end result is what is unknown. And so, for example, Kimberly has 46 stickers, Gael has 39. How many stickers do they have altogether, right? And so children will try to figure this out using a variety of different strategies. And this is when the end is unknown. Now, the second category, right, is when the change is unknown. And when the change is unknown, right, these are problems when how much is added or taken away is the unknown part. And so one example of the change unknown problem is Kimberly has 46 stickers. Gael has some stickers. Altogether, they have 85 stickers. How many stickers does Gael have, right? And so in this problem, we're solving for one of the add-ins. The number that is being added is unknown, right? And so there was a change here, right? In the middle one, we're looking for the change. And then the last category is when the start is unknown. And in start unknown problems, right, the starting amount is unknown. And an example of that would be, for example, Kimberly has some stickers. She gave 39 to Gael. Now she has 46 stickers. And so in this problem, children find out how many stickers Kimberly started with before she gave 39 to Gael, right? And so thinking of these different problem types, right, will surely help us support children in how they might approach solving these problems, right? And so this was super interesting and helpful to me, right, in thinking of problems, addition and subtraction problems divided into these three categories: end unknown, change unknown, and then start unknown. All right. And so, so far, right, we've explored what children come to understand about addition and subtraction strategies, and what strategies children might use, right? We saw a variety of those to solve addition and subtraction problems. And we also discussed some ways that we can support children in using these counting strategies to add and subtract, right? Now we can discuss more ways that we can support children in adding and subtraction. Now the M5 overview, and so we refer right to the 5 early math teaching practices as the M5 or M to the 5th early math approach, right? And these practices include all centered on mutual learning, right? Meaningful investigations, materials and learning environment, math vocabulary and discourse, multiple representations, right? And so when thinking of the M to the 5th early math approach, right, we might want to consider how might we be designing learning opportunities, right, that tap into all of these approaches. Oh, and I wasn't showing you the slide, sorry. I forgot to advance the slide. Right, and so again, mutual learning at the center, right? Meaningful investigations, materials and learning environment, access to multiple representations, and also thinking of math vocabulary and discourse, right? The language that happens in math. And so how can we support our younger learners, right, in using counting strategies and design those activities around, right, the M5 early math approach? We might want to do things like offer children support, right, or design opportunities for them that include counting using concrete objects, right, or different containers so that they compose and decompose. Counting with understanding and proficiency. This also includes, right, counting with their fingers and just finding ways so that students on their own explore with inventing, right? And so them on their own inventing and explaining different strategies that they've used. And then I know we're approaching time, right? And so we're getting close to the end of this, but I also want to highlight, right, how to support understanding of addition and subtraction and how important it is, right, to try to use authentic math problems. I know one of my colleagues the other day, Alejandra, you shared how you would include your students' name in their math problems, right? And so that doesn't take a ton of planning, but a student hearing their name show up in a math problem automatically gets them engaged and exciting for learning, right? And then the children in the class almost look forward to having it be their name show up, right? And so again, just finding ways to relate math problems to their daily experiences, or that's something that they can connect with, right? Providing concrete objects, using authentic problems, right? Or also inviting children to share their thinking and to highlight the different ways, right, that they've came or that they approached a solution or finding the solution to a math problem. And again, not focusing on finding the correct answer, but on their thinking process, right? And just highlighting how there are different ways and strategies to arrive at a solution. Different materials, right, that we can bring into our classroom. Base 10 blocks, right? 10 frames are super helpful in supporting children understand the base 10 system. Base 10 blocks and frames. Number lines, right? Number lines are super important in helping children provide or supporting children, right, with spatial cues to count and compare numbers. Number line system I mentioned earlier, super helpful in counting back. And then I'm going to go ahead and end it here, but in your participant folder, you have links to different videos that you can choose from, right? In observing the M to the 5th in action. And so you have links to different videos that you can observe, right, or watch that highlight, right, how M to the fifth in action with specifically addition and subtraction can show up, right, in your math activities for your younger students. Right. And so I'll leave that document in the participant folder with different videos that you can explore. All right. And then with that, I'm going to end it here with a quick reflection. Right now, we saw a ton. I think today was a different experience in our PL than we've had previously, right? Where it was a lot of me talking and a lot of me explaining, and we didn't get a chance for a lot of hands-on activities or play activities ourselves, right? But I really hope that in reviewing how children, right, begin to develop their understanding of adding and subtraction, the different strategies that they use, right, when solving addition and subtraction problems from pre-K to second grade was helpful to you all. And so with that, I wanted us to take just a quick minute to reflect, right, on maybe what is something that you are already doing to support children in adding and subtracting, right? Or something new maybe that you saw that you want to try to further support children or their caregivers and families, right, in supporting their children developing adding and subtracting skills. And so I'm going to invite you to just put it in the chat or unmute your mic. But what is something you're already doing, right? Because I know that a lot of this great work is already happening. Like I shared earlier, Alejandra had shared, right, how just making word problems relevant and engaging for their students. She includes our students' names in the word problems, but anything else, right, that you're already doing either to make adding and subtracting more engaging or other ways that you're supporting your students.
In my case, um, right now I'm assessing my kids, and I noticed that my 4-year-olds are up to date with counting. But I mean, just the fact that some parents think that just because their child knows how to recite the numbers, that they already know how to count. And
Mm.
so then I also get students like my 5-year-old that it's blank. But, her brain, it's picking up on a lot of the things like, like how to hold a pencil, like simple things. But, she knows quantities, right? So she may be behind on certain things, but so the way I like to do things, for example, I'm modifying right now my lesson plan in which I'm going to be doing some more hands-on activities through we're going to do cooking. So simple things, like we're gonna be reading the La Gallinita Roja, the little red hen. And so she's baking something. So we're gonna talk about procedures, we're gonna talk about numbers, and we're gonna be making pancakes
Oh,
with the
nice.
students. So they get to, add how many cups, how many so we're gonna be measuring and doing that. So no, of course, numbers are gonna be there.
Right, right.
So
And then for some of your students, right, who are maybe just beginning to develop that understanding of adding and subtracting, right? For them, remember, we don't have to necessarily attach numerals yet. We're developing
nope.
conceptual
Hmm.
understanding, and for them, it's if you're making chocolate chip pancakes, right, and you start off with one chocolate chip and you add up and you add a set. Now you can say, I added, is there more or is there less, right? They don't have
Hmm.
to count them yet. They don't have to write the number yet. But if they understand, hey, when I added some chocolate chips or whatever it is, right? Now this made
Hmm.
more. And so finding
Yeah.
finding where to begin with students, right? And meeting them where they're at to continue supporting them, right? So thank you
Hmm.
so much for sharing. And then that literacy connection too is so important, right? And so literacy, yes, and math and connecting those two. That's a great idea. Thank you, Veronica, for sharing. Anyone else want to share quickly before we go?
So I wanted to share, like, I remember the song Tengo una muñeca vestida de azul. that I learned in Mexico, right? So like using, and that one has like addition on it, right? Dos y dos son cuatro y cuatro y dos son seis. Dos. So like I would teach that to like my kids when I taught like first grade, right? But also there's like a whole bunch of other songs that you can teach them, right? That just helps them kind of like remember some of those patterns in numbers, right? It's not so much the rote memorization, but it's them seeing the patterns that are within the numbers that they can do. And songs just are things that kids like. So.
Yes, and then years later we'll see we're still singing the song, right? But it helps and it's effective and they love it and they have fun and they're playing and it's developing their mathematical understanding. And so yes, great idea. Thank you so much, Alejandra, for sharing. All right. So with that, right, we're at the end of our session, and so I'm just gonna put the Denise, thank you so much. She's already done that for us. But she just put the feedback form in our chat. And so we do appreciate your feedback. Let me go back to this one. Just a quick reminder, we'll be reaching out to make sure that everyone has an opportunity to complete those coaching sessions, right? And then our last session of the year, you made it through a whole year, scheduled for June 2nd from 3:30 to 5:30, right? And that one will be focusing on STEAM for everybody, right? STEAM for all, sparking inclusive learning with UDL. And so looking forward to that session, to staying connected. And then again, we'll be reaching out soon to make sure, right, that we deliver those Amazon gift cards to you and hopefully, right, are some support in purchasing the materials that you might need in implementing some of the activities that you've seen in our sessions. All right, everybody, it's 5:24. Thank you so much for joining us today and taking time from your busy lives. Thank you so much. Have a great rest of your evening.